Hello, everyone. My name is Eyal Rozen, and I'm from Morphisec. Together with me is Mr. Thomas Geyer, also from Morphisec, and Mr. Steffen Prell from Rheinmetall. And the three of us will speak today about moving target defense and proactive prevention. So, Steffen, maybe you can start with a short intro about Rheinmetall and the partnership between Rheinmetall and Morphisec.
Yeah. So thanks for this, Eyal. My name is Steffen Prell. I am the General Manager of Rheinmetall International Services based in Abu Dhabi. Now I want to take a short introduction about the Rheinmetall Group. Rheinmetall Group is a very traditional, very old company established in 1889, a long time ago. And in the meantime, it is split up into the core two corporate sectors, which is Rheinmetall Automotive and Rheinmetall Defense. The values, as you can see on the slide of 2019, is we had 2.7 billion euro sales in the automotive sector. And in the Rheinmetall defense sector, we had 3.5 billion in 2019. Both of the divisions are each split up into three different business divisions, which are called mechatronics, hard parts, and aftermarket. In automotive and in defense, we do have the sections about weapon ammunition, vehicles, but also electronic solutions. I think it rings a bell for most of in the audience. Rheinmetall Group is listed in the German MDAX since a very long time, and yeah, the growth proved successful even now during the COVID times. Coming to the next slide, I want to tell you basically my history together with Morphisec. I can tell you when we did the opening of Rheinmetall International Services back in 2016, we had a business requirement to build a state-of-the-art and self-operated data center with the possibility to clone the same later for further and other different regions for self-operated IT and administration infrastructure. So on our shopping list, we did have a state-of-the-art endpoint protection. Clearly, we did state that we need to run this autonomously in-house, even the full life cycle. That means from implementation with our own team to operations, maintenance, and when you have the patches, when you have the maintenance activities, they also are performed, of course, in collaboration with the OEM, but they are performed by the in-house team. Clear to say, we did check for the best performance instead of the best name. So we were focusing also on smaller companies, on dedicated features. So we didn't have a shopping list which was based on names. We did have a shopping list or a list of requirements which is based on features, on applications, what to do and what to protect. After this personal meeting back in 2016, we started 2017 to build and go live with this in-house data center. We had a very close collaboration with the team from Morphisec from the beginning. All the training sessions, in-house operations proved successful because we didn't have any a data breach. Whatever Morphisec is supposed to find was found. In 2018, we had several other deep dive tech sessions for operators. We did also discuss an integration of existing product bundles from the Rheinmetall side. We did, and partially this is still ongoing, it's a long-term project, that we have a feasibility about the integration of self-developed prototypes. Also, the combination of other products which are already available on the market. In 2019, we started a first, we call it an internal multiplication, because all of a sudden we had to build a similar layout like the one that we developed back in Abu Dhabi in a different country. Morphisec basically achieved to be one of the must-have solutions, and all of the maintenance, the implementation, the updates and everything is now clearly part of our must-have agenda. The training includes be a Morphisec administrator in our own training protocols. In 2020, we do look into a partnership with Morphisec. It was something which was considered to be a regional concept, but now we are talking about some global aspect as well. We have the possibility to do the resales as Morphisec. We have to do the possibility of renaming and sell it as a Rheinmetall product, and of course, put it into a bundle with existing products owned and from other parties. So this is a very interesting and promising partnership, which, as you can see, we are running since several years very successfully. And we are very happy to be part of this convention. We wait for your questions and can recommend that you have a similar Morphisec experience like we have. Thank you very much.
Okay, thank you very much, Steffen. Thank you, appreciate it. And moving on to the next slide and speaking about the technology. How do we achieve prevention? Now, to explain about prevention, let's speak about, or to put things in the right perspective, let's speak about the three main elements that are what is called today the endpoint security world. And when we speak about endpoint security, we speak about prevention, detection, and remediation. These are the three main concepts. Prevention is the proactive approach of keeping attacks out of the network altogether, where detection and remediation, that by the way usually go together, are a more reactive approach, which are post-breach, meaning they assume that at some point in time the network will be breached. Now, what will be the necessary steps to take in order to detect what breached the network, and what will be the steps to take in order to do the damage control, the remediation. Now, from a strategic point of view, I believe, and I'm sure you will agree, that prevention is where the focus should be, because if you're able to take the prevention, the proactive approach, you don't have to worry basically about detection and remediation. And by the way, this was indeed the case a few years back, when there were a lot fewer attacks and they were a lot simpler by nature. And leading antiviruses at that time, and I'm speaking about 5-6 years ago and so forth, they had the prior knowledge, and this is a very important point to emphasize. These antiviruses had the prior knowledge about those few attacks at the time, and therefore they could prevent them. But over the years, and you can see this in the slide because the slide reflects a case by which prevention is not under focus. What happened is that the attacks have become a lot more complex and a lot more difficult to prevent, and B, there are a lot more attacks. And a few years back, 2, 3, 4 years ago, vendors had no other choice but to fall back on detection and remediation, and this is where we are today. Now, what Morphisec is bringing to the table, we are bringing back the focus on prevention. So basically, moving target defense, and I'll touch that, is a technology which enables doing prevention, okay, and keeping attacks out of the network. Moving target defense is usually implemented in protecting the memory and is very, very efficient, as I will explain, on preventing evasive attacks, trying to use the memory of the endpoint as their gateway into the network. A bit about moving target defense and why moving target defense is so innovative. And in order to understand that, let's first try to see and understand how do traditional solutions work? How do legacy vendors operate? So when we speak about the memory of the endpoint, and this is what we're focusing on, we're speaking about the loading phase of the application. Okay, this loading phase of any Windows-based application is the phase in which the application is vulnerable for exploits. So any application that I am using occasionally will have vulnerability in it. One of the DLL files will be vulnerable for various reasons. And throughout the loading process of the application is when this vulnerability is exploitable, is exposed to attacks. The problem is that the loading process, the memory structures are always done in the same way. The loading process, Windows loading process, is always done in the exact same way per any application. The process repeats itself time and time again for years, and we call it static. It's static because it happens in the same way, it doesn't change, and as anything static, it is therefore easy to attack. And the only way to defend it nowadays is by placing rings of protection around it. So none of the companies, none of the vendors try with the existing technologies to change something inside the memory structure. What they do is placing rings of protection around this static nature of memory processes, of the memory structure. And these rings of protection can be a next generation antivirus, as you see here in the slide. They can be a high-end EDR solution, but nothing is being changed in the memory structure itself. And the problem with this is that eventually, and we see this on a daily basis, eventually the attackers who have all the time in the world, if they focus on a specific organization to study these rings of protection, they will eventually find a way to bypass and to penetrate and to reach the memory structures and to use the loading process, as I mentioned before, as a phase in which they will append themselves into this vulnerable file and eventually penetrate the endpoint through the memory. Now, what moving target defense manages to do, instead of placing rings and rings of protection and not touching anything inside the memory itself, moving target defense takes a different approach and basically moves the memory structures inside the memory, changing the rules of the game, okay? Now changing the static nature of the memory structure into a moving target, making it very difficult to attack and making it easy to defend, and changing the rule of the game. Now it's the attackers who need to chase what the defenders are doing inside the memory. This basically is moving target defense. And this is how it works. You see here an outline of an endpoint. An endpoint in principle consists of two main elements. It includes a disk drive and includes the memory. Also, you see here on the slide a bunch of Windows-based applications, very commonly used Windows-based applications. This slide shows some Office applications, it shows some internet browsers and so forth. All these applications, and by the way, what I'm about to explain applies to any Windows-based application, not only these Windows-based applications that you can see on the slide, but any Windows-based application whatsoever, even your own homegrown application, proprietary application that you developed on your own and only your organization is using. As long as it's Windows-based, this explanation applies 100% to that application as well. All these applications, by default, by principle, are stored on the disk drive of the endpoint. And I'm going to use Google Chrome as my example, but again, to emphasize, this is only an example and it applies to any Windows-based application. I can trigger Google Chrome either by double-clicking on its icon on the desktop of my endpoint, or I can double-click on an email attachment that will provoke it to load, right? Doesn't really matter. But once I double-click on it, what happens is it starts to load. What does it mean it starts to load? It means that Windows, or rather an entity in Windows, which is called the Windows Loader, will start loading the DLL files that put together Google Chrome and which are all stored on the disk drive of the endpoint, like I've mentioned. It will start loading them into the memory of the endpoint, as you can see on the slide. Now, it doesn't just throw them into the memory, which is very vast and large. It will create a memory structure, which is like a closed container, inside which these DLLs will start to load and to form the application, in my example, Google Chrome. Windows Loader doesn't just sporadically load the DLL files into the memory structure. It does it according to very specific rules, which are referred to as the rules of Windows. These rules of Windows include a few very strict rules that need to be followed in order for the application to be successfully loaded in the Windows environment. They can include, for instance, a naming convention. Windows Loader provides a name for each DLL. So now each DLL will have a name such as A.DLL, B.DLL, and so forth. These rules include the fact that the DLLs load according to a certain pattern which they form, which is unique to the application that I'm loading. One of these rules can speak about the sequence by which these DLLs are loaded. Some DLLs load before other DLLs, and so forth and so forth. Again, in order for my application to properly load in the Windows environment, it must follow these rules. And every time I load a Windows-based application, that is exactly what happens. The Windows loader will take the DLL files from the disk drive and load it according to the rules of Windows inside the original memory structure. This is what I meant before as a static nature, as this process happens in the exact same way time after time again, no matter which application I'm opening. Now let's put a caveat for a minute and look at things from the aspect of an attacker. And I want to use the process that I just mentioned in order to create an attack that will be a memory-based attack. So now I understand the rules of Windows, which, by the way, are easy to learn, and Microsoft even publicizes them on the open internet to encourage individuals to create Windows-based applications. So I'm an attacker, I go to the Microsoft website, and I very easily learn these rules of Windows. Now the next thing I need to do is to identify which of these applications include some kind of vulnerability, and this happens all the time. Google Chrome specifically had a vulnerability about a couple of months ago. Microsoft introduces patches on a regular basis to cover vulnerabilities. So all the applications include vulnerabilities all the time. If I'm a good attacker, if I'm a diligent attacker, I know, for instance, in Google Chrome that there is a specific vulnerability. And now, throughout the fact that I studied and I'm aware of the rules of Windows, I know that this vulnerable DLL will always receive the name B.DLL, for instance, by these rules of Windows. And the rules of Windows will apply or imply that this B.DLL file will always be placed at this specific location inside the memory structure. Now that I know the name and I know where to find it, it's easy for me to orchestrate an attack which will know which DLL to call for and where to look for it. So this is exactly how memory-based attacks work. Now, what does moving target defense, what does prevention do in order to stop this? Moving target defense takes two main steps. The first step, which is maybe the most important, is called morphing. The technology takes this original memory structure, which includes passive actions, okay, or a static approach, which again happens the same time again and again and again. And most importantly, is what the attack has been programmed, reverse engineered to find, to address. Moving target defense takes this memory structure and it morphs it. What is the meaning by morphing? It means that it takes this application memory and turns it into something which is unrecognizable to the attack. The application memory that originally looked like this, now all of a sudden looks completely different. Moving target defense takes 6 different actions inside the application memory, such as renaming the DLL files and shifting their location and changing a bunch of other parameters that eventually turn the morphed application memory into something which the attack cannot even recognize. It cannot recognize, and it will not address, it will not even approach the morphed application memory looking for the vulnerability it was programmed to find. If this happens, already the impact of prevention is achieved, because if by taking these steps, we turn the application memory into something which looks completely different, invisible basically to the attack, and the attack will not even approach it searching for the vulnerability, prevention is already achieved. And this is exactly what happens. From the flow perspective, moving target defense includes a client installed on the endpoint, okay? This client is idle most of the time. Once a Windows-based application is triggered, throughout the loading process, the client wakes up, it does the morphing that I just mentioned. If there is no attack on the endpoint, then the application which has been triggered will load seamlessly and transparently through the morphed application memory with the user feeling nothing, okay, as if it was loaded through the original memory structure. But if there is an attack on the endpoint, this attack will not recognize a morphed application memory and is basically helpless. It can attack nothing because it sees nothing, okay? This is how basically moving target defense works. Moving target defense takes another step, which is the creation, as you can see here on the left, of a lightweight skeleton trap. The reason for the creation of the trap is that the solution includes a management console, providing visibility to the network, and the trap is essential in order for collecting forensics data of the attack and sending it to this management console. How does a trap do it? The trap from the outside looks identical to the original memory structure, which is what the attack has been orchestrated, has been reverse engineered to identify. So now the attack sees something it identifies, it will approach this skeleton of the application memory, believing that it's the real application memory, searching for the vulnerability it was programmed to search. And by approaching this skeleton is enough for the system, for the solution to take a snapshot of this area of the runtime memory and send the data with all the forensics information to the management console. Naturally, the attack will not find any vulnerability here because this is only a skeleton. It's basically hollow. So with these two steps, A, the attack has been prevented, B, forensics information has been collected and sent to the management console, providing the network administrator, the security manager, with all the information of an attack tried to attack your endpoint, Mr. Security Administrator, but moving target defense technology has managed to prevent this attack. These are the two main steps taken by the technology. With these two steps, three very important differentiators are achieved. A, pure prevention, and not only pure prevention, but prevention which is not dependent in any way on any prior knowledge. Because mind you, with this flow that I've just outlined, no hunting or detection actions have been taken. And everything is done in a complete agnostic manner to the attack. So the solution knows how to prevent an attack without needing to know anything about it. And this is a very, very dramatic differentiator in reference to any other solution out there today, which constantly scans, consuming resources and trying to cross-reference what it found to what it knows. Any original solution includes some kind of database, so to say, with a bunch of attacks that it is aware of. And if it encounters something new, it tries to cross-reference it to this knowledge it has. And if it does not have this knowledge, it is completely helpless. It cannot stop this attack. Unlike moving target defense, which is completely agnostic in its nature to the type of attack. And this is the most important thing. The second differentiator is the deterministic approach. The deterministic approach means a very marginal number of false positive alerts, unlike the traditional solutions, which try to create some kind of baseline and to screen per any abnormality in this baseline, many times incorrect of their assumption, therefore creating a very huge amount of false positives. This solution, or in this solution, by definition, anything which reaches the skeleton application memory will be malicious by default. So We don't state that moving target defense has no false positives, no solution has 0 false positives, but in a conceptual level, it's a very, very marginal number. And this is a second very important differentiator. The third one is referred to as resilience. And by resilience, we are speaking about the fact that each time that moving target defense morphs the application memory, it randomizes the steps it takes in order to do the morphing. And by this, it basically eliminates any chance of an adversary, of an attacker, to overcome the steps that are taken and to bypass the solution. So this solution has been deployed today globally on more than 5.5 million endpoints, be it PCs, laptops, servers, etc., and it has never been bypassed. So these are 3 very important differentiators. In this slide, I will speak very briefly about the fact that moving target defense is not only efficient in the execution phase of the attack, which everyone is aware of, but also in the 2 preliminary and very important phases of the attack, which most individuals and companies do not address, which is the infiltration and pre-execution. This is why we call the solution a defense in depth solution, because it is efficient in stopping an attack not only in the last phase, but also in the 2 preliminary ones. And I'll touch that in another slide. The other part of this slide speaks about different attack vectors. So other solutions are efficient with e-downloads or attachments, because attachments are a very common way for attacks to exploit themselves. But moving target defense is very efficient in other attack vectors as well, such as web browsers, which most solutions do not address, and of course the physical and the network elements as well. So basically, this comes to show the coverage, and this comes to explain why this solution is a pure defense in depth solution. So I mentioned defense in depth and the fact that prevention and moving target defense can stop an attack at the very beginning, not only in the execution phase. And this slide comes to visualize this, and it takes a real example from August 2019, a real attack which was based on vulnerability in Apple's iTunes version for Windows. Okay, Apple iTunes version for Windows had vulnerability in it, which was later patched by Apple. But moving target defense was a solution that, for the very first time, managed to prevent an attack which exploited this vulnerability. And this, again, is a real example. And first, I will speak about what happened with this attack in reference to traditional solutions. So, with traditional solutions, companies who used iTunes for Windows and suffered from this vulnerability, okay, had attacks which started all the way in the beginning in August of 2019. They didn't even know that they were attacked. We call this the unknown of the unknown. The first unknown is that we have an unknown attack, a new attack, a zero-day attack that the traditional solutions don't know about, okay? Second unknown refers to the fact that the companies that were attacked didn't even know that they were attacked by this zero-day attack. And all the way from August 2019 and until mid-October of 2019, these attacks, or this attack, was sitting inside these organizations, infiltrating the organization and laterally spreading from one endpoint to the other in the pre-execution phase without no one in the organization feeling or knowing that they've been attacked. Only towards the end of 2019 is where the execution took place and the organization felt they were attacked. People came to the office in the morning, they opened their laptops, they saw a blue screen, their data was encrypted, etc. This is not where things end. This is where things start, because now the organization is bombarded with calls by users claiming that they cannot work. The organization's IT or security department needs to immediately contact Apple to request a patch so additional attacks will not exploit this vulnerability. Then they need to publish articles and issue compliance reports as the governments impose. And last but not least, they need to contact their AV vendors who are completely useless and ask for updates. So from August 2019 and all the way at least till the end of November, these organizations all suffered from disruption of business because all this hassle, okay, impacts business and companies lose money. And we read about this every day. With moving target defense and prevention, companies are protected from day one. So no infiltration and no pre-execution and no execution and no panic in none of these phases need to take place. Protection is from the very, very beginning. So no disruption of business and no loss of money. And by the way, many organizations hear about moving target defense and turn to prevention, to this prevention-based solution, unfortunately, after they've been attacked and after they lost a huge amount of money. Another thing to emphasize on is the power of server protection using moving target defense. And this is a Gartner slide that was copied and pasted into this presentation. What Gartner, which is a very trusted analyst company, says is that nowadays, speaking about servers, Gartner takes under consideration that almost every serious organization will take two main steps: hardening and configuration of servers and network firewalling. Assuming that these steps take place, pay attention, antivirus and EDR solutions are perceived as nice to have only. And what Gartner emphasized as mandatory is exploit prevention, memory protection, which is exactly what moving target defense does, and application control and whitelisting. So these two solutions go together, and these are what provide the most efficient protection of servers nowadays. Last but not least, moving target defense has been deployed by Morphisec on more than 5 million users worldwide among more than 500 enterprises. And you can see some very large names here, such as BlackRock in the United States, Yes Bank in India, Maersk, which is, I think, the largest shipping company in the world, Motorola, Orange, and of course, other companies as well. And we're working with some very big names as partners. I hope I managed to convey the essence of moving target defense and the importance of prevention. And now I will switch over to Thomas in order to provide a quick summary in German. Thomas, over to you.
Thanks so much, Eyal. Thanks for your presentation. Ja, mein Name ist Thomas Geyer. Ich bin Repräsentant für Morphisec in Deutschland. Ich bin stationiert in München und darf für Sie nochmal die wichtigsten Punkte zusammenfassen. Ich möchte das an 4 Punkten detaillierter machen. Der Punkt 1 ist das Prinzip des Moving Targets, das wir bei Morphisec verwenden. Das heißt, dass wir durch die flexible Speicherverwaltung im Gegensatz zu konventioneller Speicherverwaltung potenzieller Schadsoftware ins Leere laufen lassen. Das bedeutet, sie findet nicht mehr die Ressourcen, die sie erwartet zu finden. Gleichzeitig sammeln wir alle möglichen forensischen Informationen, um nachher auch die potenziellen Schadsoftwaren auszuwerten und Informationen daraus zu generieren. Der zweite Punkt ist, dass wir proaktiv anstelle reaktiv arbeiten. Das heißt, konventionelle Schadsoftwareerkennung arbeitet nach dem Prinzip, dass man erkannt hat, dass ein Angriff stattgefunden hat und jetzt potenzielle Schäden verhindert. Und durch das Prinzip der flexiblen Speicherverwaltung können wir bereits Angriffe initial unterbinden. Das dritte ist, dass wir auch Schutz vor unbekannten Attacken liefern. Eyal hat das in seiner Präsentation auch als Day One Protection oder am Exploit des Unknown Unknowns erklärt. Das bedeutet, dass wir diese kritische Phase zwischen dem Auftreten von neuen Attacken und entsprechenden Security Patches der Hersteller, die in Eyals Beispiel 3 Monate, glaube ich, gedauert hat, aber in jedem Fall kritisch ist, unterbinden können. Das heißt, wir sind nicht auf diese Patches angewiesen, sondern durch das Prinzip des Moving Targets können wir solche Attacken auch schon von Day One an unterbinden. Und last but not least ist, dass das Prinzip von Morphisec extrem leichtgewichtig ist. Ich hatte mal was von 3 Megabyte gehört und beansprucht praktisch keine Systemressourcen. Es sind keine zusätzlichen Updates von Schadsoftware-Signaturen erforderlich. Das heißt auch keine Verteilung von solchen Schadsoftware-Signaturen im Unternehmensnetz und ein Einsatz des Prinzips oder von Morphisec parallel zu konventionellen Schadsoftware-Erkennungen ist dadurch auch problemlos möglich. Das sind die 4 wesentlichen Punkte, auf die wir nochmal für alle Teilnehmer, die es auch gerne nochmal auf Deutsch hätten, in aller Kürze hinweisen wollten. Wir hoffen, die Präsentation hat Ihnen gefallen und stehen Ihnen natürlich jederzeit für weitere Fragen zur Verfügung. Vielen Dank für Ihre Aufmerksamkeit. Eyal, that's from my side. Back to you.
Okay, let me show my face again. Thomas, thank you so much. And thank you, Steffen. And of course, thank you everyone for listening. And I hope to receive your questions and I'll be very happy to address all of them. And with this, we end our session. Thank you very much.